purpose of this video is to show how to complete step 21 here, which is basically running a simulation and generating code for one of these subsystems within the simulation. So you have to go to your MATLAB terminal here, and you have to navigate to your GitHub folder that you made. I have a name Simscape model. Navigate there. Have to wait a moment. Then the file structure loads up. First thing you want to do is run the startup file. This loads up all the parameters that is used within the simulation. This takes a moment to do. And there you go. You see there on the left all the different structs, and each of them has all the numbers that are required. So the next thing is to open up Control Loop Simulation SLX. This is and just click Open Model. This is the overall closed loop model and that I've been using. It has a vehicle, a driver, and a controller. It takes a while to load up here. Once it does, I can show you how to use it. It's actually quite simple, and because all these parameters on the right there are loaded up, so you can literally just click Run here, and it should work. Just going to wait here till it compiles. Alright, so it's almost done here. This bottom bar here to tell you the status of the simulation. So now it's running, and it tells you at what time step it's at right now. And you can see that the simulation is progressing as one would expect. Once this happens, you know that everything has been configured correctly. You have all the add-ons and compilers that you need. You can just now click Stop here. That is now step, let's see. That's part A and B here, complete. So now moving on to code generation. This is, you need to navigate all the way up to the top level of the simulation. And from that point, you go to Apps, drop down, and find Embedded Coder. The idea of what we're doing here is that where you want to take one of the controllers within this subsystem and translate all that code into C code. Right now it's written in Simulink, which can't be uploaded onto our microcontrollers. But C code can. So that's what we're doing here. So I navigated to Quick Start there. Next, you want to select the controller as specified, Sensor Fusion. And next, so C code, that's what we want, and multiple instance. This means that, well, we're running it multiple times, the same code, and that is indeed what we are doing. So I did make a mistake here. It says accelerator mode is not supported through model command. Now, the mistake I made is that I was running the simulation in accelerator mode, which is longer compilation time but faster execution time. But to code generate, you have to be in normal mode. So if I do the quick start again here, Sensor Fusion, next. Then this is the first time you have to wait while it This program looks around, determines what it needs to do to be able to code generate. The reason why I do code generation from MATLAB instead of writing directly all my code in C is because it is much easier to verify that the code is working within the MATLAB environment. C code, to program a vehicle model in C would be horrendous. It's already bad as it is in MATLAB, and in C would be even worse. So now the analysis has completed successfully, so we can just click next here. Right here, you're specifying what microcontroller you want this code to run on. For us, it's ARM compatible Cortex-M. That's what I have here. If you don't have ARM Cortex-M, you didn't install an add-on that you really should have. So you need to go back and make sure all the add-ons you've installed are all the add-ons you need to install are indeed installed. So here, of course, we want to execute as fast as possible. And now this is the final part and where the program actually does the code generation. This also takes a bit of time. So the really good thing here is that once the code has been verified within Simulink, this auto code generation process is extremely accurate. It is, what is it, like FAA certified, meaning it is suitable. It is something this code generation can be used in an engineering environment for control systems on aircraft, which is, if you know anything about the regulations surrounding aircraft, that is extremely, extremely big deal. To be FAA certified is quite difficult, so this code generation process is pretty much the best way to go from MATLAB code to C code. All right, so as you can see here, code generation is complete. You have a little pop-up here on the side that shows the main code that it was generated. It's quite a long function, but that is it. If you have configured the code generation correctly, then that is all you need to do. And if you go to the file system here, back to that Simscape model folder, there should be a new folder, sensor ERT-RTW. This is where all your files are, your main C file, some header files, data files, and all this is what you use, just literally copy pasting almost entirely with very little modification into the microcontroller to be flashed. And that is it. We're now done.